functions, we come across the concept of a composite functions, and it's basically combining two or more functions together to get a single function. So the way we write that is f of g of x. Now, another way to write that is f with a circle g. That's another way of writing this. So what happens is that we've got, if we were to calculate this, we do g of x first. So if we go back to our concept of a black box, we're going to input x into the first black box, which is g, and out will come g of x. Now that will be inputted to another black box, which is the f box, or the f function, and so out will come f of g of x. So g of x was our input, and so out will come that. Now, what the composite function allows us to do is to actually come up with one single function that will take x in and go out, and it will give us the output. All right, so how would we calculate that? So we know that g of x is our first function, which is this one here. That has got to be inputted into the f function. So f g of x be equal to, this has got to be inputted into that. So wherever I see an x up here, I've got to put the output of the g, which is the 2x plus 2. So that is the input. So that'll be 3. Now it is whatever squared, and we put in this function here, 2x plus 2, and then we've got to take 1. And when we multiply that out, we've got 3. Now we just use FOIL. First one squared would be 4x squared, outer, so it'll be just the 2 plus 4, then twice that will be plus 8x, and then minus 1. So 2x plus 2, 2x plus 2, first, outer, inner, and then last. Now when we combine the inner and the outer, we get 4x and 4x, and we get the 8x. So I've sort of done a bit of a shorthand way there of doing it. All right, we've got to remove our brackets, so we get 12x squared plus 24x plus, now 3 4s are 12, minus 1 will be 11. So this function here is a single function given some x value of getting straight to the output from there, rather than actually put an x value into the g function first and get a value, and then put that function into the f value and get another, and get out this here. We've been able to go straight to it. Another way to combine these functions to make composite functions is to find g f of x. So that's also a composite function. Another way of writing that would be by putting that down. So this says that the f function is input to the g function. Now the g function is 2 times something plus 2. Now instead of that x, I simply write the f of x, which is 3x squared minus 1. So that one's a little bit easier to calculate, because all we do is remove the brackets, and we get 6x squared minus 2 plus 2, which will be just equal to 6x squared. Okay, so that will take an x value and work out what our final answer would be if we put that same x value into the f function, and then the output that we'll put into the g function. and where we would end up. Just to show that, so we had x equals 3. All right, now if we put that in the f function first, we would get, so f of 3. So if we put 3 in there, we would get 3 times 3 squared minus 1, which would be equal to 3 3s are 9, 27 minus 1, 26. And then if we put that into the g function, we'd get 2 times 26 plus 2, which would be equal to 52 plus 2 is 54. Okay, so what we've done is got a value of x, just pull some value out. We've put it into the f function first, and then the answer that comes out of that goes into the g function, and we get 54. Now what we're saying is that by doing composite functions, if we put this an original value in here, we should get the final one. So fg of f of 3 will be equal to, here's my function, so it'll be 6 times 3 squared equals 6 times 9, which is equal to 54, which simply just verifies that we get the same value. So composite functions allows us to combine functions together. If we go back to our mapping concept, it allows us to come up with a single function that allows us to combine individual functions to determine a final answer.